All right, we're starting section 1.6a today. You don't have to take a picture of this one. Hang on. But we're going to be solving all types of different equations. In 1.6, 1.7, and 1.8, we're solving all kinds of equations, real and imaginary solutions. All right, most of these are going to be able to be factored. We always want to factor out the GCF. The variable is in the first term. If it's a square of the middle term, you can use substitution. That's going to be the second part of this lesson. Today we're just doing the first part, the first 9 examples. We'll talk about that in a minute. Take a picture. All right, look at the first example. All right, we're going to solve. What I want to bring to your attention is a few things. First of all, when we have something like this, we have to solve with variables on both sides. They're both x, just one's the fourth, one's the second. What should we do? Should we just go ahead and just divide both sides by 3 and then divide by x squared? No, let's move everything to one side and set equal to 0. So 3x to the fourth minus 48x squared equals 0. What is the highest exponent you guys see? 4. That means you should have how many answers? 4. They may all be real. Some may be real, something like that. But keep that in mind. The highest exponent is how many answers you should get. So let's just go through and solve this. If we're going to factor, what's the first thing we look for? GCF. What can I take out of 3x to the fourth and negative 48x squared? 3x squared. So when I do that, what am I left with? What's 3x to the fourth divided by 3x squared? X squared minus, what's 48 divided by 3? 16. Good. Your x squareds cancel. So we're good now. Can I factor this a little bit more? Yeah, so I have 3x squared, x plus 4, and x minus 4. I set every single piece equal to 0. Does everybody understand that? So I have 3x squared equals 0, x plus 4 equals 0, and x minus 4 equals 0. So my first little problem here, I divide both sides by 3. I get x squared equals 0. And then I do what? I take the square root. What goes in front of your answer when you take the square root? Plus or minus? Is there such thing as a plus or minus 0? No, but understand that you do have the answer of 0 here. How many times? Twice, because it's positive or negative. In this case, because it's 0, you don't put the plus or minus. But if it was a 4, you'd have plus minus 2. If it was a 10, you'd have plus minus radical 10. Everybody understand that? All right. Over here, I have x equals what? Negative 4. And here I have x equals what? Positive 4. Everybody with me? Okay, so there's our 4 answers.
That's not 4.
It is 4 because x squared, what goes in front of x squared? You'd have plus or minus, right? Yeah. The only case where you don't put the plus or minus is because it's 0, because there is no positive or negative 0. But if it was any other number, you would put plus or minus, and it would be 2 answers. That's called multiplicity. You have the same answer twice. All right, moving along here. Everything is on one side of the equal sign. Let's go ahead and try and factor. What's the first thing we do? Take out the GCF. What's the GCF between 9x to the fourth and 12x squared? Okay, I'm going to take out a 3x squared, and I'm left with 3x squared minus what? Okay, equals 0. Can I factor 3x squared minus 4? Off the top of your head, is that the difference of perfect squares? No? Okay, so let's just go ahead and then go to the solving part. So I have 3x squared equals 0. 3x squared minus 4 equals 0. How many answers should I get, guys? How many total? There should be 4. So I'm going to divide both sides here by 3. I have x squared still equals 0. Take the square root. I have x equals what? How many times? 2. Do you need to write it twice? No. So now over here, we're just going to go about solving. I want x squared by itself. So I'm going to add 4 to both sides. 3x squared equals 4. Divide both sides by 3. Everybody with me? X squared equals 4/3. What do? Take the square root. What goes in front of your answer? So x equals plus minus. You can break up that square root. Square root of the numerator, square root of the denominator. What's the square root of the numerator? 2 over what? Excuse me, square root of 3. Do we leave it like that? No. So what do I need to multiply top and bottom by? The square root of 3. So I have x equals plus minus 2 root 3 over 3. Is that a real answer?
No.
it's real. Are there any imaginaries in there? Is there a negative underneath? Is it a pretty answer? No, but would that be real easy to throw back in and check? Yeah, it's not that bad, but it's not as easy as plugging in 0, right? But there's no imaginaries because there's no negative where? Underneath the square root. Good. Okay, let's look at the next one. 4 terms. Sometimes you guys, when we were having when we had problems like this on our first section, like 1.4, we had some issues. If you are trying to factor, you have to have everything on one side. If you have 4 terms, what do? We group. There's no GCF to take out of all 4. So let's group the first 2 and the second 2. Keep that third sign with that third term. So what can I take out of x cubed and x squared? I'm going to take out that x squared and I'm left with x minus 3, correct? What am I going to take out of 3x minus 9? What kind of 3? A positive 3, and I'm left with x minus 3. Good. What is my new GCF that I've just uncovered? What's the GCF? X minus 3. How many times do we write it out in front? 1 time, guys. You don't write that twice. There's not 2 of them. There's only 1. And then the leftovers get their own parentheses. So I have x squared plus 3 equals what? 0. All right, let's look at the beginning again. How many answers should I have? 3. Okay. Can you factor x squared plus 3 anymore? No. So I'm just going to say x minus 3 equals 0 and x squared plus 3 equals 0. So on the left-hand side, I have x equals what number? 3. All right. Over here, I have x squared equals negative 3. What do? Take the square root. What do you know is going to happen here with this answer? Why is it going to be imaginary? As soon as you see that negative underneath, you guys should rewrite it or think it's 3 times negative 1. What is the square root of negative 1? I. And then what is the square root of 3? We don't know, right? What am I missing on my answer? A plus or minus in front. Now think about this. This is why I'm going to keep saying this, guys. Just say you're running through this and you're going fast and you're like, okay, I root 3. Take a second and go, okay, how many answers should I have? 3? How many do I have? And then you're like, wait, I only have 2? Because you might have forgotten something. So just try to check yourself as much as possible. Questions? We're okay? All right, let's look at number 4. Everything's set equal to 0? We're on one side set equal to 0? Okay, how many terms? 4. Is there a GCF? No. So what do I do when there's 4 terms, there's no GCF to take out, and everything is on one side, 0 is on the other? We're going to group. Good. You're going to keep, guys, you've got to keep that third term is negative 2. You got to keep that negative with it. So in my first binomial, x cubed minus 5x squared, what can I take out? X squared, and I'm left with x minus 5. Perfect. What am I taking out of this second set? Negative 2, and I'm left with x minus 5. Good. What's the whole reason we group? So you find the new GCF. You can figure out what's missing or what they both have in common. So I'm going to write my x minus 5 out in front 1 time. And then what do I do with these leftovers? They get their own, they get their own parenthesis. Good. Very good, guys. So now I look and I say, okay, can I factor x squared minus 2 anymore? Is that the difference of perfect squares? No. All right, so let's just go ahead and set. So x minus 5 equals what? 0. And x squared minus 2 equals 0. So on the left-hand side, we have x equals what number? 5. Good. And then over here, we have x squared equals 2. Take the square root. What goes in front of your answer? Plus or minus. And what's the square root of 2 off the top of your head? Just leave it as root 2. Now, look at the beginning. How many answers should we have had? 3. How many do we have? 3. Are they all real? Yes. Very good. All right, questions? Everybody's okay? All right, let's get to the next. All right, here we go. Look at this problem, all right? Let's see. We're going to try and factor first. Do I have everything on one side of my equal sign set equal to 0? We're good? All right. Is there a GCF? Looks like there should be. What do you know for a fact right off the top? 3. Okay, the x and the 3. Okay, so if I'm going to take out 3x, we divide everything by 3x. I should write it. Remember, guys, you have to write it out in front. That does not go anywhere. It's still part of your problem, and it's a part of your answer. When you divide out the 3x, what are we left with? 2x squared minus 9x minus 18. Very good. Very good, very good, very good. Now, at this point, your problem, your directions were to solve. What is the easiest thing to do? We know a bunch of ways to solve. You can factor, right? What's another way we could solve? Say it again. The quadratic formula, or what? Complete the square, okay? My suggestion, again, it's personal preference, but for time's sake and for ease, you should always try to factor first. So I'm going to keep my 3x hanging out here. I'm going to multiply a times c. What's 2 times negative 18? Negative 36. All right, what are my factors of negative 36? I'm going to multiply to give me negative 36 and add to give me negative 9. Good. X minus 12 and x plus 3. Take that a term, divide both of your factors by the a term. So when we simplify, we have 3x times what? What's my first binomial? X minus 6, good, and 2x plus 3, perfect. Now what do I do with each piece? I set equal to 0. So sometimes, guys, we forget about this 3x that we factored out at the front. Remember, how many highest exponent, it tells me I have how many answers? 3. So just keep checking yourself so you guys don't make silly mistakes. This is a lot to remember, a lot to think of as we go through and problem solve, so you got to make sure you're on top of it. So I'm going to divide, ooh, bad color choice. I'm going to divide both sides by 3, so x equals what in this case? 0, good. X equals what here? 6, and x equals what here? Negative 3 over 2. Good job. Questions? No? All right, let's scoot on over to number 6. This one looks a little different. GCF? No. Can I use the quadratic formula on this? Why not? Because the highest exponent that you can use quadratic formula for is squared. So what in the world is this? This looks a little weird. Trinomial? It is a trinomial, good. Can we factor this trinomial, guys? Let's think about it. If x squared was at the front, we would say x and x in each parenthesis, right? Well, what could how is there a way that I could make x to the 4th? X squared and, okay, that works. Are there factors of positive 2 that multiply to give me positive 2 but add to give me a negative 3? Negative 2 and negative 1, okay. Does that work? Yeah, okay. Can I factor anything anymore? X squared minus 2 is definitely not the difference of perfect squares, but is there anything else hidden in there? What would this become? X plus 1 and x minus 1. There you go. Good job. So now what do I do with each piece? Set it equal to x squared minus 2 equals 0. X plus 1 equals 0. X minus 1 equals 0. Good job. So I'm going to add 2 to both sides. I get x squared equals 2. How do I get my answer? Take the square root. Good. What goes in front of my answer? Plus or minus. Do we know the square root of 2 off the top of our head? No. What are my answers over here? X equals negative 1. X equals positive 1. Some of you are going to say, can I write x equals plus minus 1? Sure. But don't forget to put the plus minus. Some of us forgot that on our tests. And as soon as you looked at it, you're like, oh, I'm so mad at myself. That's okay. You already did. You just weren't here. I'll give it back to you. All right, let's look at number 7. All right, number 7 kind of looks like the one we just did. But let's check it out. Is there a GCF? No. Is this a trinomial that we could factor? It sure is. What goes in the front of each parenthesis? X squared and x squared. Great. What are the factors of positive 12 that multiply to give me positive 12 but add to give me a negative 7? Negative 4 and negative 3. Great. Is there anything else I can break down? X squared minus 4 becomes plus 2 minus 2. And then I have x squared minus 3. Is it imperative that you break that down? What would happen if I left it as x squared minus 4 and then I solved? I'd still get the same thing. My issue with that, though, is when you guys have higher exponents than squared, sometimes I want to say there's answers hidden in there that you miss. Sometimes when you have imaginary roots and real roots, if all you do is go from not the simplest form, not the most factored form, and then you solve, you miss the roots that are imaginary. Sometimes, too, if we do this, a lot of you are in a hurry. You get here, you say x squared equals 4, and then you'll tell me, oh, x equals 2, and you're proud of yourself and you move on. Is my answer here x equals 2? No, it's what? Plus or minus 2. So I would get in the habit of fully factoring everything and then go ahead and set equal to 0. So here I have x equals negative 2. Here I have x equals positive 2. And what is this going to become? X equals what? If I have x squared minus 3, what's my answer there? Plus or minus square root of 3. Good. Are these real or imaginary? Or a combination of both? They're all real. Are they all pretty? No, but that's okay. All right. We okay? Can I move on? All right. Let's look at the next one. Anything? Okay, 3x squared, 3x squared. Does this look like a perfect square trinomial? Well, let's check it out. So I have 3x squared and 3x squared, correct? And then I have 2 and 2. How do I figure out if this will actually be a perfect square trinomial? Multiply the A and the C, and then do what? Times it by 2. So 3 times 2 is 6, and 6 times 2 is 12. Is this a perfect square trinomial? No, but I'm very glad that you saw that, right? So look, that's why we need to check. Some of you will say, oh, it's a perfect square trinomial, and then just throw that in as 3x squared plus 2, square the binomial, say, oh, I got it right. Check your work. That's good that you saw that, but then we need to follow through and check it. So now we're going to go back and we're going to say, okay, wait a second. I got to factor this a different way. Is there a GCF? Can I take something out of 9, 37, and 4? No. All right, well, there's how many terms here? 3. What do we do when we have 3 terms? What do we try and do? Because I can't use the quadratic formula because it's to the 4th power. Let's multiply A times C. See if we can figure this out. 9 times 4 is 36. Are there factors of 36, guys, that'll multiply to give you 36 but add to give you a negative 37? Yup. What's going to go in the front of each of my parentheses? X squared, X squared. What are my factors? Negative 36, good, and negative 1, good. Now, before you just go and solve that and say, oh, okay, it's going to be plus minus 6, plus minus 1, guys, what do we have to do? Divide both by your A terms. So I end up here with x squared minus 4, correct? You guys with me? And 9x squared minus 1, okay. Can I factor that more? Yeah. I sure can. So this becomes x what? X plus 2, x minus 2. All right. What can I do here? What can I do with 9x squared minus 1? 3x plus 1, 3x minus 1. Good. Very good, guys. So how many answers are we going to have to this problem? 4. But we already knew that from the beginning, correct? So you have here x equals plus minus 2, and you have x equals plus minus 1/3. You can write them all out separately. You can write plus minus. I'm fine with either. Questions? Concerns? Comments? Everybody's okay? All right. Move along, move along. What? What? You guys have all seen this before. First of all, what's underneath my 1 here? A 1, okay. How do I go about solving that? What kind of a problem is this? What do we call these? Remember? God bless you. Say it again. They're fractions. What's the grown-up way of saying a fraction? Rationals. Oh, we're so fancy when we say rationals. What's a common denominator going to be between 1, x to the first, and x squared? X squared. Okay, so let's think about this. I want all of my rationals, I want all my fractions to have x squared as a denominator. So if I want 1 to have a denominator of x squared, what do I have to multiply the bottom by? X squared, which you do to the bottom, you do where? To the top. So I have x squared plus, my second fraction is 3 over x. What do I multiply x by to make it x squared? What you do to the bottom, you do where? To the top. So plus 3x equals, what do I need to do here? Anything? Yes, no, maybe?
Where did you get the 3x from?
I multiplied, it just didn't go. If you multiply the bottom by x, then we have to multiply the top by x, right?
The other x.
It didn't, I wrote it, but the tip of my Apple Pencil is
I
being.
didn't see the x squared because someone's head was popping.
Oh, how dare their head be there? All right, do I have to do anything with my negative 2?
No.
No, because I already have x squared. All right, so now, can I just take the square root of both sides?
I have a question though.
Yep, talk to me.
Why did you take out the denominator for the second term?
Say it again.
For 3 over x.
I didn't take it out. I'm trying to get all of our denominators to be the same, x squared.
Oh, okay. I got it.
Can I solve just like it is right now? Can I just go ahead and say, okay, I'm going to square root both sides? No. All right, so what do I need to do? Where should I move things? Tell me, talk to me. Okay, you're going to move the 2 to, okay, perfect. So plus 2 equals 0. All right, now guys, I did not tell you how to solve. I just said solve this. So what are my options? What could I do? You could factor. We always want to try that first. But what's another thing? If you're just like, I don't feel like it. Quadratic formula or, okay, which is fine. So let's see first of all if this factors, because if it doesn't, it makes life a lot easier. A times C. What are the factors of 2 that multiply to give me 2 but add to give me 3? X plus 2 and x plus 1 equals 0. Yeah? So what are my two answers? X equals negative 2 and x equals negative 1. No, I pat myself on the back and I say, okay, I'm so glad I'm right. Or what should we do? Why should we plug it back in? Just to make sure there's no what? What do we call those? Extraneous solutions. Okay, so let's practice that. If I plug in negative 2, I have 1 plus 3 over negative 2 equals negative 2 over what? Negative 2 squared. So I have, what's another way I could write 1? 1 over 1, okay. If I'm going to add these two together, or subtract them, really what you're doing, what do I need to have? A common denominator. What's my common denominator going to be between 1 and 2? Okay, so we're going to make this a 2, then this becomes a 2? You guys agree? Okay, so this is 2 minus 3 over 2 plus a negative. You guys good? Or no? Okay, so then I have negative 2 over 4. What's 2 minus 3? So negative 1/2 equals what? Negative 1/2. We're good? Okay, let's try 2. We're just practicing. I just want you guys to practice. So plus 3 over negative 2. Did I just try negative 2? I need negative 1, my bad. So negative 1 equals negative 2 over negative 1 squared. Agreed? Okay, so 1 plus a negative, this is just what? 1 minus 3 equals negative 2 over what? 1. What's 1 minus 3? Negative 2 equals what? We're good? Okay, I want you guys, I know some of you are really great about this. You keep on your test or quiz till the very end and you check everything. Some of you think you're going to get extra points if you turn your quiz in first. You don't. Take your time and check. Just always go back to check to see if there's extraneous solutions for certain situations, to see if you made silly math errors. Ari, you get so mad at yourself, don't you? When you say, oh, I can't believe I just did that. 2 plus 3 is not 6, right? Just go back and check. You guys will help yourself out.